Let's look at trigonometry. And normally I call this the first question, so I call it question 1, and it involves us using a diagram. So normally what they'll give you is a condition. So and I'm going to give you the condition in 3 ways, and then I'm going to show you how you're going to go about it. So let's look at question 1. This is the first part of the condition. If tan theta is equal to 3 over 4 and theta is between 360 and 180. Now, when you see this, most of us would want to rush to draw the diagram. Yes, most of us would want to rush and draw the diagram. And we all know the diagram. Most of us will say all silly T Tom cats, or all stations to Cape Town, or you can give this any acronym you want. CAST. Some people use CAST. But what it basically means is that you are supposed to draw a triangle in one of those quadrants. This is what we are going to say is that triangle 1 will be a 90-degree triangle, and it will sit on the x-axis. In other words, if I am just going to give you some, so I can draw the triangle in this way. It can be this one, it can be this one. Can you see my 90 degrees is along the x-axis? It can be this one, or it can be this one. Can you see it forms sort of like a bow tie? You know, the tie that those people who are rich they wear when they are going to parties. Or even some people who want to look smart can wear it, but we call it a bow tie. Now, when you look at that, I have got 4 triangles, and only one of those 4 triangles is going to represent this condition here, according to this information, which is the domain that we've been given. So we want to know which of those triangles it is. So now I will look at my tan theta. If I look at my tan theta, I will notice that here tan theta is what? It's positive. Tan theta is positive. Then, and I look at my acronym, all of them should be positive here. So which means tan is also positive here. If I look here, tan is not positive. But if I also come here, tan is positive there. So tan is positive in 2 places. Tan is positive here, and tan is positive there. Because our fraction did not have a negative sign, that is why we are saying they want a tan which is positive. But now, between the 2 tans that we've been given, we now need to decide which tan is the correct one. Now, if I look at the domain, they said I must start from 180 and I must go to 360. So if I start from 180 and go to 360, so this is 0, 90, 180, 270, and then 360, which means I've gone a full circle. It means I've created an angle which runs a full circle. Now, clearly, if that means I am dealing with this area here from 180 going to 360. Now, if you look carefully now, which triangle do you think is going to be the one which we're supposed to use? Obviously, now you are going to say, oh, well, I'm supposed to use this triangle. I'm supposed to use this triangle here. Yes. So now you have an idea of where to put your triangle. But that's the job half done. That is the job half done. And if it's the job half done, then we must now see what else we can do. Now remember we said our tan is positive, so now we have made our decision. We have said that okay, our tan is going to be in this quadrant. So we said our tan is positive, so we said our tan has to be in this quadrant here. So I draw a triangle like that. Now what does the 3 and the 4 represent? If you look at your tan and you are going to say, in this particular case, the 3, tan is opposite over adjacent. And you must know this from your grade 10. Tan theta is opposite over adjacent. Now, our opposite line is always the x-axis, so the y-axis. And our adjacent line is always the x-axis, like that. So which means that if my triangle is sitting on that Cartesian plane, and we are saying there the opposite must be represented by 3. Remember we only use the numbers, it's a positive 3, and the adjacent, now the adjacent is not on the, sorry, so the opposite is represented by the 3 there, and the adjacent is represented by a 4. Now you can clearly see that there's something wrong with that 3 and 4 if we are looking at the x-axis and the y-axis. The adjacent, which is 4, is on the wrong side. It's supposed to be positive, but clearly if we are going to relate it to the triangle, it's not positive. So but logically we would say no, this has to be a negative. And also the opposite, which is the 3, has to be a negative. So it means that both of them were negatives, which means that the reason why we got a positive there is because we had a negative 3 divided by a negative 4. It's always good to never assume that the number you are using is positive or it's negative. You will find out after you have looked at the diagram. Now let's look at how we find this line here. Now this line is very simple. Here we are using our Pythagoras theorem. So our Pythagoras theorem would say hypotenuse squared is equal to opposite squared plus adjacent squared, which means that if I want my hypotenuse, which is this one, some people call it r squared is equal to opposite it's y squared plus x squared, which means that I now know that the distance on the y-axis, if some people put the negative 3, but it's not need, there's no need for you to put the negative because it's distance 3 squared plus 4 squared, which means that r squared is equal to 25, which means if I want r, I find the square root of 25, which is going to be 5. So my r is immediately going to become 5. And now I've now got all the information on my diagram. I can now go ahead. Normally I want to go ahead and write my ratios. Immediately I go ahead and write my ratios somewhere. I know that tan theta is equal to 3 over 4. Cos theta is adjacent over hypotenuse. Now adjacent in this case, here is our adjacent there. There is our adjacent there. Let's just cos theta, there is our adjacent there. Cos theta is negative 4, which is the adjacent, over the hypotenuse, which is 5, which we calculated. And then finally, sine theta will give us, our opposite is negative 3, because sine theta is opposite of hypotenuse, and our hypotenuse is the one we calculated is 5. Now once I've got these, I've written them down, I am now ready to answer the other questions. Now if we now look at another case and how they present this question, if they were giving me this question here and they wanted me to work it out, let's say they give me the diagram is already drawn. Question 2, here now they draw the diagram for you. It's a very nice neat trick. They draw the diagram for you like so, and then they put a point, and this one is 8 and minus 3. Now then they ask you to find theta, find the ratios. Now here I can simply find my ratio. The theta is normally starting from 0 going way around, even though some people want the theta to be the triangle. My triangle will always be there. Even though they put the theta there, your triangle will always sit on the x-axis, never on the y. So now on that triangle, I now need to see what these numbers are giving me. The -3 is coming to give me this one, and the 8 will come and give me this one, which means I am left to find the hypotenuse. So the hypotenuse in this case, hypotenuse squared is equal to opposite squared plus adjacent squared, which is r squared is equal to, this is our r, is equal to y squared plus x squared. Now my y is going to be 3 squared, my x squared is going to be 8 squared. This is going to give me this is going to give me r squared is equal to 64 plus 9 is 73. That's r squared is going to give me that. R is going to give me square root of 73. So I can just go ahead and write square root of 73 there, like that, to show that I've now found. So if I am going to write down my ratios, I know that tan theta is equal to opposite, which is -3, over adjacent, which is 8. Then cos theta is going to be adjacent, which is 8, over the hypotenuse, which is square root of 73. And then lastly, then sine theta is equal to -3 over square root of 73. Now I've given you two situations, and now let's look at our last example, where now it's not just how we draw the diagram and the information we get from the diagram. Here now we want to see us answering a dummy question. I call them dummy questions because you can always create your own. And in a dummy question, I normally ask simple questions to get my brain stimulated. So I say, if tan theta, I'm using the first case, is equal to -3 over 4. I like that one. And then they say theta is between 0 and 180. This should be interesting, and it's negative. So now they say find. Now they want you to answer questions, and we have to answer questions because we have to get to a certain point. Find sine theta. That's the first very easy question. Then I'll say find sine squared theta. A tricky question because it is something that some people always forget, so I like asking this question. And then next one, now they're going to say find cos 2 theta. Now I'm now saying, remember the identities we talked about? Those identities, I want to see, can you use them? Wait, I want to check if you can understand the other identity also. Sine theta over 2 cos theta over 2. Eish. I've got everything messed up now. It is now ugly. So here now we are asking you to apply the identities, and I'm going to apply something else. which we are going to learn later on, but I'm just going to show you, and then maybe you can come back to this video when you have done reduction. So then we say cos 90 minus theta. Beautiful. So these are sort of like the common questions that would almost come with this type of question, where you are applying the identities, you are applying the double angle, you are applying the reduction, and they are also checking on the square to see, do you understand your square? So let's start by drawing the diagram. So in this case, I need to be a bit more careful. I'm going to use a small space, so I'm going to use A there. I'm going to answer A somewhere here. Now with A, they're asking us to find sine theta, but we're not going to go straight into answering that question. We're going to go first of all into answering our diagram. 1, 2, 3, 4, 5, 6, and then I'll delete whatever I don't need. 1, 2, 3, 4, 5, 6, 7, 9. Okay, there you go. Just need that, yes. So it's gonna be, now I need to draw the diagram. So the diagram, I'm going to draw it using, there you go, I'm drawing the diagram. Then I'm saying, oh, they have asked me to draw a diagram. Where is my diagram going to be? Now theta, tan theta is negative. Tan theta is negative. So I can check and say, okay, fine, I'm not going to draw all the triangles this time. I know that tan is positive here and tan is positive here. So those are the two areas where tan is positive, which means the two remaining areas tan is negative, which means that my triangle can be here or it can be here. Which one is the correct one? So if you look carefully, I said from 0 to 180. From 0 to 180 would mean that starting from here, from here to there. So clearly, if you look at this one, it's not going to work, isn't it? That one is not going to work. So we're going to go ahead and remove that. There's my rubber. I'm going to remove that. And now that I know the area which I'm working with, I'm also going to remove all these other things which I was using to show you so that my diagram is not too messy. So now I'm back to my diagram, and I have to draw my diagram now, and I know that my diagram is going to be somewhere here. So I draw my 90 degree there, and then triangle there. So now I know that the opposite is -3. So -3 is on the y-axis, which is the opposite. So that's gonna be -3. Now let's look at the adjacent. It's gonna be 4, so it's gonna be 4 there. Now if I want to find my r, I'm just going to do r is equal to 3 squared plus 4 squared. That's r squared. R is going to be equal to 5. By now you should be able to work out your r, because this is a revision tutorial. Now once you've got that, you now need to use that to find the sine. So if I want to find the sine, then I'm going to use this same diagram, and they've asked me to find sine. So let me just make a duplicate of that. So there. So I want to find sine. So sine is going to be sine theta is opposite. I'm going to just show the full working. Opposite over hypotenuse. Do you see I've written my sine theta there? This is what they want. So I'm finding that. So sine theta is equal to opposite over hypotenuse. So if they want sine theta is opposite is -3 over hypotenuse is now 5, and I'm done. Let's go to B. We still have the same diagram, but now they are talking of sine squared theta. Now I must write sine squared theta is the same as opposite over hypotenuse squared. Do you notice that I'm only using opposite and hypotenuse, and you must get used to practicing doing this. And then now remember, our opposite is -3 over our hypotenuse is 5. So then you square it, which will then eventually give you 9 over 25. So this one is now done. Now let's go to the next one. The next one now is saying cos 2 theta. Cos 2 theta, in this case, we must now remember that cos 2 theta. Aha! You take out your formula sheet. This looks familiar. So I know that cos theta is going to be 2 cos squared theta minus 1. So I need to replace the 2 again, but remember now cos is adjacent over hypotenuse squared minus 1. Now what is my adjacent? My adjacent in this case, this is a -4 because of where it is, isn't it? And this is a +3, sorry. I think I used the wrong one, so we need to be very careful there. And then this is going to be 2 -4 over hypotenuse is 5, and then there's going to be a squared -1. So now this is going to give us what? 16 times 2, that's going to be 32 over 25 minus 1. You can then use your calculator. Let's go to the next one, the last one. So the next one is going to be sine theta over 2 cos theta over 2. Now of course this one is a very special one because it becomes sine theta, which is 1 over 2 according to that identity. Now remember, our sine theta is half opposite over hypotenuse but remember our opposite is going to be 3. It's not -3. Sorry, I think I made a mistake previously. It's going to be 3, and it's going to be half times 3 over 5, which is basically 3 over 10. So remember, when you do the first one, this one is not -3, it's +3 over 5. So we had made a mistake here. We're not supposed to put a negative there. Okay, mistakes are common, and always accept your mistakes, and I'm one who always accepts my mistakes. So there you go. Let's go to the last one. Here we've got cos 90 minus theta. This is going to give us cosine theta, and which is again opposite over hypotenuse, and then this is going to be 3 over 5. And that, ladies and gentlemen, is how we do that first question for the diagram. Please note that when we were working out the first one here, if we look at the first one, I did put a minus sign there. That minus sign is not supposed to be there. It's supposed to be a positive. So yeah, it's good that I noticed it. And also the next one, let's just look at the next one. Yeah, the next one had a minus, but it didn't really affect it. But still, it was a mistake that we shouldn't be making at this time. Remember, you always watch out, you always look at what you've done, and always check to see if you have made mistakes. Okay.